which will match the feed line impedance to the load impedance. So each time I have to allow in Cisco Webex, but what is the problem? Previously you were joining automatically. So how to match the feed line, transmission line of characteristic impedance Z naught, transmission line of characteristic impedance Z naught with the load having the impedance, complex impedance ZL. In between we need a matching network. Okay. So this ZL could be this is equal to in general RL plus JX. Combination of resistance, capacitance and inductance. RL. So okay. So it has a resistive part, reactive part. We have to match Z naught with ZL using a single stub tuner. So again we have to test whether series or shunt. We want to place the stub with the feed line, that means with this line feed line, in series or in shunt. So basically then we have two types of single stub matching, series single stub and shunt stub. So we will discuss both. Also for double stub, we have both the cases in principle. But generally we go for a shunt type for double stub. So see here single stub matching network, both shunt and series is shown here. Single stub tuning, shunt stub, series stub. So single stub shunt stub, it is in shunt with the feed line. It is in shunt with the feed line, which I told you, you can see. And then we have a transmission line section. So basically we are connecting the stub. The question is where to connect the stub. So at a distance d from the load, where to connect the stub at a distance d from the load. At a distance d from the. So in this case, basically what we have to find, make the circuit. Here we have the transmission line, and here we have load. So at a distance d from the load, at a distance d from the load, this is also a transmission line of characteristic admittance Y naught. Y. So here we will connect the stub. So you have to match it. So here we will connect the stub. This is also a transmission line only. So admittance is or characteristic impedance is that is Y naught For this transmission line, we have Y naught here. For this also Y naught, and for this also. For the stub also it is Y naught. Okay, so basically now our job is to find this position of the stub. This is the position of the stub, shunt stub. Here is shunt stub, single shunt stub, and the length of the shunt stub. Length of the stub. What is the length of that? So we have to find D and L stub. How to find? How to find it? ZL is equal to RL plus JXL. YL is equal to 1 upon ZL is equal to 1 upon RL plus JXL. Here you are using shunt stub. How to find? Yes. What we can do? To match Y naught with ZL. What we can do? So here ZL is equal to RL plus JXL is equal to 1 upon. So what will be the impedance here? That is the question. What will be the impedance? What will be that impedance? This impedance Z is equal to, what is the general formula? Z naught into ZL plus J Z naught tan beta into D. Tan beta into D? Yes, tan beta into D here. And Z naught plus J ZL tan beta. This is the formula. So Z is equal to basically Z naught into ZL plus J Z naught tan beta D. That is correct. Divide by Z naught. So this is Z. And Z is equal to 1 upon Y. There should not be any problem. Z is equal to 1 upon Y, and Y is equal to G plus JV. Conductance and susceptance. Shunt susceptance. Y is equal to G plus JV. So basically Y is equal to 1 YZ, and Z we have here. Y is equal to 1 upon Z is equal to G plus JV, and is equal to, can you reverse it? Can you write 1 upon Z? So if you reverse it, it will become Z naught plus J ZL tan beta D divided by Z naught into ZL plus J Z naught tan beta. And also write ZL is equal to RL plus JXL. So if you write that, then what it will become? Put ZL is equal to RL plus JXL. So ZL is equal to RL plus JXL. So here RL plus JXL, and here also RL plus J. Okay. So if you solve this equation, can you calculate G and V complex number by equating the real and imaginary part? What is the real part of the admittance Y and imaginary part of the admittance Y, G and V? Can you calculate G and V? So can you calculate G and V? What is the value? What is the value? What is the value of G and V? After solving this equation, so I have to clean it, then I can write. Okay, so I will clean it. So what is G and V? It is here. G is equal to tan beta d. RL into 1 plus P square, RL square plus XL plus Z naught P. Yes. So G is equal to, what is G? Conductance G, real part of Y, RL into 1 plus T square. And T is basically tan square beta d here. Divide Y RL square plus XL plus Z naught P. So XL plus Z naught tan beta d. And what is B? B is the imaginary part, acceptance of. So B is imaginary part of Y, imaginary part of Y. So that is equal to, again, one complex expression which is written here, that you can calculate G and V, no problem. So now what is desired? So basically G and V we can calculate. So what could be the value of G? Down length D from the load. What should be the value of the G? G should be equal to basically 1 upon Y naught for the machine. G should be equal to 1 upon Y naught. G should be equal to 1 upon Y naught and B. So the susceptance of the shunt stub for machine should be equal to minus B. So now those conditions you can apply. G is equal to 1 upon Y naught and the susceptance of the shunt susceptance should be equal to negative of the B. Negative of B. So these two conditions you apply here. G is equal to 1 upon Y naught. Put here G is equal to 1 upon Y. G is equal to not 1 upon Y naught. G is equal to Y. 1 upon Z naught. So condition number 1, G is equal to 1 upon Z naught is equal to Y naught. And second, the susceptance, that is B, this B should be equal to, so negative of B is equal to susceptance of shunt stuff. So susceptance of shunt stuff should be equal to minus B. These two conditions are required for matching ZL with Z0. Matching ZL with Z0 using shunt stuff. So shunt stuff G is equal to Y0 and minus B is equal to susceptance of shunt. If you apply these two conditions, you can find the position of the stuff from the load and length of the shunt stuff. Using these two conditions, you can find these two parameters. See here, same thing is done. G is equal to Y naught 1 upon Z naught. So G is equal to 1 upon Z naught, and you have got a quadratic equation if RL is not equal to Z naught. But suppose Zn is equal to RL plus JXL, and suppose RL is equal to Z naught. In that case, there is no problem. You can put RL is equal to Z naught here, and you can solve it, and you will get this. Then you will get T is equal to minus XL upon 2 Z naught. T is equal to 10 beta D. Here it is T. Because if Z naught is equal to RL, then this will be this denominator. Numerator is okay, but denominator will be, so for that case, when RL is equal to Z naught, better you put in this quadratic equation, RL is equal to Z naught. So if you put here RL is equal to Z naught, you will easily get T is equal to minus XL by 2 Z naught from this quadratic equation. And what is T? T is 10 beta D. T is 10 beta D. So T you have got, which is 10 beta D. So 10 2 pi y lambda D. So basically dy lambda will be equal to 1 upon 2 pi 10 inverse T. 1 upon 2 pi 10 inverse T. Again, if T is greater than 0, and you know this trigonometric inverse rule. So if T is less than 0, then what will be D? Because you are interested in D. So D will be equal to 1 upon 2 pi 10 inverse dy lambda 10 inverse T if T is greater than or is equal to 0. But if T is less than 0, then what will happen? Then dy lambda for that case, dy lambda for this case, dy lambda will be equal to 1 upon 2 pi 10 inverse pi. What will be the thing then? 10 inverse pi plus T. Is it correct? From trigonometry, if T is less than 0, if this thing is less than 0, if it is negative, then dy lambda will be 10 inverse pi plus T 1 upon 2 pi. So from here basically we can calculate, no, it is, why asking you, pi plus 10 inverse. It is not correct. It will be basically pi plus 10 inverse T. You have to add pi, 1 upon 2 pi, pi plus 10 inverse T. So how this is happening? If T is negative, then it is equal to pi plus 10 inverse T, right? What is 10? 180 degree plus theta. It is tan theta. What is tan theta minus 180 degree? Because 180 is pi. So what is tan theta minus pi? Tan theta minus pi is equal to tan theta. Am I correct or not? So if I write here tan theta minus pi, so that means tan beta d minus pi, it will be equal to, it is equal to t. Okay. So tan inverse t plus pi is equal to 2 pi dy lambda. So basically d will be equal to 1 upon dy lambda will be equal to 1 upon 2 pi plus tan inverse t. This is what is written finally here. But you didn't tell me. I have to do all this calculation. But now it is proved how it is like that. So little bit mathematics I also know. Okay. Okay. So next we calculated t. Here dy lambda is done for both the cases. Okay. So now what about the length of the stuff? What about the length of the stuff? How to calculate? I told you what is the condition. The condition for calculating the length of the stuff, this is position of course. So this we have done is equal to 1 upon 2 pi tan inverse t provided t is greater than equal to 0. And this is equal to pi plus tan inverse t provided t is less than 0. For all t less than 0. Okay. Now how to calculate the length of the stuff? For calculating the length of the stuff, I told you that minus b, negative of the susceptance of y, that means negative of the imaginary part of y, is equal to the susceptance of center stuff. So now you have chosen center stuff, that is very nice, but open circuited or short circuited, that is the question. It is a center stuff, no doubt, it is a center stuff, but open circuited or short circuited, that is the question. That means at the end it is open circuited or it is shorted. This stuff I am talking. So if a transmission line, because this is also a section of transmission line only. So if a transmission line is short circuited at the end, what will be the impedance? What will be the impedance of a short circuited transmission line? J Z0 tan beta into L. This is length. J Z0 tan beta L. And if it is open circuited, then what will happen? If it is open circuited, then what will happen? Minus J Z0 cot beta L. Minus J Z0 cot beta L. This is the impedance. So now what will be the admittance? YSC. YSC will be equal to minus J Y naught cot beta L. And admittance of the open circuited it will be equal to J Y naught tan beta L. Yes, J Y naught tan beta L. I am saying that this will be equal to susceptance of the shunt stub is equal to minus B. Minus B. This is equal to minus B. Whether you use series or this short or open, your wish, no problem. Suppose you use short shunt stub. In that case, what will happen? Minus j y naught cot beta L, where L is the length of the stub which we need to calculate, is equal to minus. Can you solve this to find L stub? Beta is equal to, of course, 2 pi by lambda. So minus j y naught cot 2 pi L stub y lambda is equal to minus B. Minus minus cancel. So what will be length of a stub? Can we calculate length of a stub here? Frequency will be given. Of course, you can calculate lambda. Y naught will be given to you. Impedance of the transmission line, feed line. So this way we calculate the length of the stub analytically. Not using Smith chart. This is analytically. So see here, Ls by lambda 1 upon 2 pi tan inverse y naught upon V. Tan inverse y naught upon V. And my dear, one more thing. Why we are keeping J here? Because that is when we are writing G plus JV, this J is in Y. Imaginary part of Y is basically equal to JV. Imaginary part of Y is V. So what is susceptance? JV. Conductance and susceptance. So this JV should be equal to, so JJ will be cancelled. So what will be the length of the stub? It is sorted shunt stub. Sorted. So what will be length? That will be 1 upon 2 pi length of a stub divided by lambda. Okay, 1 upon 2 pi tan in, this is cot inverse, na? Cot inverse. So cot inverse B upon y naught. Cot inverse B upon y naught. So what is tan inverse and cot inverse relation? See here. Cot inverse B upon y naught. Here it is written tan inverse y naught upon V. So tan theta and cot theta, how it is related, you know? If tan theta is equal to x upon y, what will be cot theta? Y upon x. Y upon x. So tan inverse, basically it will be cot inverse y B upon y naught. So y naught upon B. Or directly you can solve this. So that is for short circuited stub, and for open circuited you will get a minus sign. How? Because see here, in open circuited, Y open circuited is equal to J Y naught tan beta L is here minus V. Minus V. So you will get a minus sign. And what will be that? This is okay. We have done Ls upon lambda, Y naught upon B. This will be minus 1 upon 2 pi tan inverse V upon just the reverse, and this minus sign. So you have calculated D and length of the stub analytically. Now we can do for series stub. We can do for series stub. So for the series stub, here is the case. Single stub, single series stub, tuning circuit. Single series stub tuning circuit. How a stub is connected here? How the stub is connected here? It is connected in series with the feed line. Series stub is connected in series with the feed line at a distance d from the load. Okay. So now how to do the calculation for d and length of a stub? Length of a stub. So how to do that calculation for the single series stub matching circuit. So here we have transmission line Z0 and it is connected in series with the transmission. It could be open circuited or short circuited at the end. That is not a problem. And here we have Z and down length D from the load we have a transmission line. So this is of course D that we have to find, and it is the length of the stub that we have to find. This is also Z0. It is also Z0 or Y0. So now what to do? How to solve it? How to solve it? Again, we will calculate what is the impedance here. So this is what is the impedance here. Z is equal to 1 upon Y. So real part of Z and imaginary part of R plus Jx, we can write R plus Jx. And what will be the condition? Real part of Z. So real part of Z, that is R, should be equal to Z0, and imaginary part of Z, so that is minus X. That should be equal to susceptance, this reactance, because series stub. So reactance of the series stub, then it will be cancelled. So here Z is equal to 1 upon Y. Okay, Z is equal to R plus Jx. Z is equal to R plus Jx. R is equal to Z0. R is equal to Z0. You will get a condition. And reactance is the negative of the stub reactance XS. That same thing it is done. Reactance is the negative of the stub reactance. So this is X stub is equal to minus. These two conditions we can use for calculating D and L stub. D stub, L stub. So basically Z is equal to 1 upon Y is equal to R plus Jx. What will be the admittance here? What will be Y? We know the formula for Z in. So Y in, what will be Y in here? Input admittance. Z in is equal to Z0 into that formula you know. What will be Y in? Tan theta divided by Z0 plus J ZL tan. What will be Y in? that will be equal to y naught into yl plus jy naught tan theta divide by y naught plus JYL tan theta. You check whether it is correct or not. If it is correct, then we can proceed. Just reverse it. Put Z naught is equal to 1 upon Y naught. Put ZL is equal to 1 upon YL and check whether it is correct or not. Is it having the same form or a different form? So Y in is equal to Y naught into YL plus JY naught tan theta. This is correct. So if this is correct, then YL it is given, ZL is given. So ZL is given RL plus JXL or GL plus JVL is equal to YL. So GL plus JVL for YL we can write GL plus JVL here and also here. So basically you know how to do it. So what you will do? Y in which is equal to this thing and Y is equal to 1 upon Z to 1 upon R plus Jx because Z is 1 upon R, Z is equal to R plus Jx. So this way you can calculate R and X. Then put R is equal to Z naught and X is equal to minus X. Same process for that we did for center. For single series stubs, again a stub could be open circuited or short circuited at the end. So again those things you have to apply. The impedance, input impedance of a circuited transmission line or open circuited transmission line. So now using Smith chart, we have to solve it. And double stub tuner we will do tomorrow. So using Smith chart, how solve this. So here is the question in front of you and we will discuss using Smith chart. Analytically we have done. Using formula is very complicated, but you can do it using formula also. MATLAB code you write. So for a load impedance ZL is equal to 60 minus J80 ohm. So here is the question for shunt stub. Design single stub short circuited stub. Okay, so single stub shunt tuning network. So it is given we have to go for short circuited stub to match this load to a 50 ohm feed line. To a 50 ohm feed line. So load is matched at 2 gigahertz, and that the load consists of a resistor and capacitor in series. So RL plus JXL, resistor and capacitor in series, R and C. In series, plot the reflection coefficient. You know that is equal to Z minus Z naught upon Z plus Z naught from 1 to 3 gigahertz for each solution. Two solutions it is talking. So first we will discuss one solution, okay? Because if you remember that quadratic equation, this quadratic equation, how many solutions you are getting? How many solutions you are getting for D, position of the stub and length of the stub? So XL plus minus, you will get two value for T. Two solution you will get. Okay, but Smith chart, using Smith chart method. So now what we will do first, we will locate a small ZL, 60 minus J80. 60 minus J80 divided by 50. So it is 1.2 minus J 1.6. 1.2 minus J 1.6. Where is that ZL? So R is equal to 1.2. It is here this circle. It is 1.2 this circle, resistance circle. R is equal to 1.2 and XL is equal to minus 1.6. So 1.2 and minus 1.6 is here 1.6. So minus 1.6. So intersection, it will give us ZL. So ZL is here. So now we have ZL. Can we go for YL? If here we have ZL, you know what will be the load admittance on the Smith chart, where it will be located on chart. So it is ZL here. So from the center, and this line will be extended, and this standing wave ratio passing through ZL, so it will be YL. So we have YL. Okay. We are at load admittance basis. So now what we have to do? Position of the stub. Position of the stub we have to calculate. So for finding the position of the stub, what we did? So from the load, we traveled a distance D to a point where Y naught is equal to the transformed admittance. So what will be that point? 1 plus Jx circuit. Where is that circuit? Because Y naught should be equal to the real part of Y that we have done just. So 1 plus Jx circle is here. You can see 1 plus Jx circle. This circle, this one. So 1 plus Jx circle from YL, this distance D1, we are here. This is the intersection point, 1 plus Jx circle. And D1, now the question is okay, so how to find D1? It's very easy, find D1 on Smith chart. So if I zoom it, what you are seeing here? What is written 1.2, 1.4, 1.6, 1.8, 2.0. So this distance is, and here, this distance is 0.17, 0.18, because we are interested in distance. So outer chart, WTG, wavelength towards generator. So that is 0.175, 0.175 minus, and for YL 0.065. So 0.175 minus 0.065 is the answer. They have taken 0.176 minus 0.065. There is no problem. I told 0.175 minus 0.065 is the answer. Now, because in this question, two single stub network they want you to design. So what is D2? So again the question is, from this YL, again we have to move and reach this circle 1 plus Jf. This circle, if you see here, this is this circle here. So you will reach here. Either you reach like this or you reach like this. Here. So what is that distance? D2 from YL. But remember, whether you are moving clockwise or anti-clockwise. So D2 distance, how we can find? So D1 distance we have calculated from YL. So what about D2? Where is D2? D2 is here. So this is 1 plus Jx circle. So it is 0.325. 0.325. So 0.325 minus 0.0625. See, it is just. So 0.325. You can also read it 0.32, 0.33, so 0.325. Okay. So 0.325 minus 0.065 is equal to D2. Wavelength towards generator of case. Outer. I am reading outer. Okay, so no problem. We will focus on D1 only. First solution. Then D2 also we calculated. Okay, now D1 is done. How to calculate the length of this? D1 we have done. So how to calculate the length of the stub? So what is the Y1? Can you locate what is Y1? Value of the Y1? So this point Y1 is equal to Y1 is equal to 1 plus J 1 plus J 1.45 if I am correct. 1.46 also you can take. So I am saying 1.1 plus J 1.47 they have. There should not be any objection. 1.45 either you take. So that in here 1.4, 1.5, 1.45 I took. 1.46 also you can take, 47 also you can take, 44. So if it is very clear to you, you can take the accurate value 1.45 I told. So 1 plus J 1.4. What will be Y2? Here is Y2. So how to locate Y2? Y2 here 1.2, 1.4, 1.6, 1.5. So again 1.45 minus 1.45. So it is minus 1. No problem. So Y1 and Y2 you know. So if you know Y1 and Y2, so how to calculate the length L1 and L2? So Y1 is equal to 1 plus J 1.45 or 1.47 as per this. Okay. So as per the year value 1.47. So if we take 1.47, so as per the theoretical discussion, basically the length of the, for finding the length of the stub, the susceptance of the stub should be equal to minus the susceptance. So we have to go for it is for first solution D1 Y1 I am talking, that is 1.47 plus. So I have to go for minus 1.47, of course, okay, as per discussion, so that it can cancel. Where is minus 1.47 or 45? It is here. Here. So it is indicated L1. Do not be confused, because you will say how it is L1 here. Because as per the discussion, to cancel the admittance of susceptance, so for length of the stub, here it is shunt stub. So basically the susceptance of the stub, it should be minus susceptance. So B, minus B. Susceptance of the stub minus minus B stub should be equal to B, where B is the imaginary part of Y. So if it is 1.47, if it is 1.1 plus J 1.47 point, if it is 1.47, so what will be B stub? We have to go for minus J 1.47. So where is minus J 1.47 on Smith chart? Where is minus J 1.47? It is here. It is here. But in the question it is given short circuited, shorted. So where is short circuit point on Smith chart? Where is TSC? Where is TSC? Where is short circuit point? So what will be the length L1? 0.3. It is what is written 333435. So 0.345 we can take. And where is the 0.345? And where is that short circuit point? Y is equal to infinity. So 0.095. 0.095. How it is coming? 0.345. 0.345 minus 0.345 minus 0.25. What is this? 0.345 minus 0.25 lambda. What is this? How much? This is 0.095 lambda. 0.095. And here what is answer? 0.095. So how I did this calculation, which I have written here? In the book only it is written. So how it came? It came like this: 0.345 lambda minus 0.25 L1. Because you have chosen sorted stub. Sorted stub means 0.25 lambda here. What about L2? Where is L2? First you look at L2. L2 is here. Again the stub is sorted only. But it is very easy to calculate. You know how? Lambda by 2 minus this distance. That's it. Lambda by 2 minus this distance. It is 0.25 and it is here 0.155. So Smith chart is very nice. Easily we are able to do. Analytical method is formula. We have derived. You can use formula. It is complicated. So next question is using single stub series tuning. Using Smith chart. Using Smith chart. Single stub. Here is the question. Series tuning. And open circuited stub is given in the question. Yes, not short circuit. Be careful. So again question is 100 plus J 80 to a 50 ohm. So after normalization 2 plus J 1.6. 2 plus J 1.6 ZL. Come here. Locate ZL. 2 plus J 1.6. So where is 2? R is equal to 2 is here. And J 1.6. So where is J 1.6? This question. ZL normalized is equal to 2 plus J 1. So where is ZL? 1.6. So we have to go here. 1.6 is here, this reactance circle, and if this circle is intersecting these two at this point. So here we have ZL. Here we have ZL. So standing wave rescue circle. So from ZL down a length D1, 1 plus Jx for matching, we are here at Z1. Can you calculate D1 easily? What will be D1? Because for matching the real part of the transformed impedance down a length D from the load should be equal to Z0. So Z0 means what? 1, normalized 1. So 1 plus Jx. It is here, this circle highlighted. So ZL to Z1. What is D1? What is the value of D1? And again it will intersect at this point Z2. But first we'll talk about Z1. So what will be D1? D1 is here and D2 is this much from ZL to D. So D1 will be equal to 0.2, 0.21. So what will be this? 0.209. Can we write 0.209? And this one here 0.32. So 0.329. So for D1, 0.329 minus 0.209. 0.209 and 0.329. 0.329 minus 0.209 is equal to 0.12. This way you can calculate D1 and D2. Okay. D1, D2 you can calculate. Now how to calculate the length of the stub? What was the condition? For calculating the length of the single series stub, what was the condition? So basically, the reactance of the single series stub should be equal to minus the transformed reactance down a length D from the load. So for that, clearly you need to find what is the value of x. Then we can take minus x, no problem. So what is the value of x? What is Z1? Simple. What is Z1? Z1 is equal to 1 minus J. You can take 1.2, 1.3. So basically you can take 1 point here, so 1.3. 1 point. How much we should take? What is your opinion? 1.2, 1.4. So 1.32 should we take or 1.33? So 1.33 or 32, whatever you would like to take. 1.33 is taken. See. So that is Z1. As per this minus 1.33. So what will be then x stub? Because minus of that. So minus J 1.33 is that is there the value. So minus of that. So J 1.33 is equal to the reactance of us. Now look at this point. J 1.3. And here in the question, open circuited stub is given. In this case, open circuited. So where is 1.3 plus 1.33 here? So it is written here. See, you can see L1 is written because we are doing B1 and L1, 1.3. So now open circuited stub is written. So how to calculate? What is the value here? 0.148 we can write or not? 0.15 to 0.148. We have done it or not? So 0.397. How it came? 0.397. So here is length L1. The location is 0.148. This is 0.49, 0.474849. So 0.5. 0.5 minus 0.148. What will be the value? 0.5 minus 0.18. What will be the value? How it is coming? 0.397 lambda L1. It is open circuited. Where is the position of the open circuit?
Rightmost side, open circuit.
Where is the position? Open circuit. PSP. Rightmost you told. So from rightmost you move this much distance. How much you will get? So do one thing. 0.5 minus 0.5 minus 0.25. First you calculate 0.25 minus this distance. 0. Let us take 148. So what is the value? 0.25 minus 0.148. If we take 1.15, then what will happen? 0.1, 0.5 minus 0.1, 0.4. What is the value here? 0.397. Okay. Because it is not 0.15, you know that. It is 0.147. Okay, so single stub, double stub, short circuited, open circuited, single series, a double stub we have not done. Single series, single shunt, short or open, we have done. Now double stub tuner, you do some practice. Smith chart. Take a print out of the Smith chart. I will share Smith chart. Impedance admittance chart and do solve this question. Then we have double stub tuning. Analytical solution using Smith chart. Both we have to do. Yes, this will be the last topic. Tomorrow I will finish, then Vasula madam will start from the next week, unit 3. Okay, so if you have any question, you can please ask me any question, any doubt we will discuss now.